Hello friends, myself R.D. Mahajan presenting my video on inverse Laplace transform revision part 2. First example, find inverse Laplace of log of root of s square plus 4 divided by s, and to determine its inverse we consider f bar of s as log of root of s square plus 4 divided by this square root means s square plus 4 that raised to 1 by 2. Therefore, taking that 1 by 2 before the log, we get 1 by 2 log of s square plus 4 minus log of s, and then differentiating this with respect to s, derivative of left hand side is f dash of s, 1 by 2 constant outside as it is. Derivative of log is 1 upon s square plus 4, chain rule, differentiation of s square is 2s minus derivative of log is 1 by s. Derivative of log s is 1 by s. And then this 2 to get cancelled, we get f dash of s as s divided by s square plus 4 minus 1 by s. Then taking inverse on both sides, therefore inverse Laplace of f dash of s and inverse Laplace of right hand side term. Individual inverse, it is inverse Laplace of s upon s square plus 4 minus inverse Laplace of 1 by s, and as per the property, inverse Laplace of f dash of s is minus t into f of t. Remember the result, inverse Laplace of f dash of s is minus t into f of t, and then it is equals to inverse of s upon s square plus 4, standard result, it is cos t, minus inverse of 1 by s is 1, and therefore next step f of t means the inverse of that f bar of s, as dividing by minus t we get 1 minus cos t whole divided by t as answer. Therefore, inverse Laplace of this function is 1 minus cos t by t. Important one is this theorem, inverse of f dash of s is minus t f of t. Remember this step. Second example, find inverse Laplace of pi by 2 minus tan inverse of 2 by s, and to determine its inverse we consider f bar of s as pi by 2 minus tan inverse of 2 by s, then differentiating this with respect to s, both sides, differentiation of left hand side is f dash of s, differentiation of right hand side, pi by 2 is constant term, is derivative 0, minus inverse of tan inverse is 1 upon 1 plus x square, therefore 1 plus x means here 2 by s whole square, applying chain rule as it is function of function. Derivative of 1 by s is minus 1 by s square, therefore it becomes minus 2 by s square. Cross multiplying here we get 2 upon s square plus 2 square upon s square, that goes to numerator, therefore it becomes 2s square, and into 1 by s square. S square get cancelled, we get that value as 2 divided by s square plus 2 square as f dash of s, and then differentiating, taking inverse on both sides, inverse Laplace on both sides, Therefore, next step, inverse Laplace of left hand side, inverse Laplace of right hand side term. Inverse of f dash of s, standard result, it is minus t, or using a property, its inverse is minus t into f of t is equals to 2 constant outside. Inverse of 1 upon s square plus a square is 1 by a, 1 by 2 sine of at, sine of 2t. And therefore, f of t is equals to 2 to get cancelled, dividing by minus t, we get its value as minus sine of 2t divided by as a required inverse Laplace transform, or as answer. Once again, this step is important. Inverse Laplace of f dash of s is minus t into f of t, where f of t means the inverse of that f bar of s. Example number 3rd. Solve this differential equation, dy by dt square plus y is equal to t, and the conditions are y of 0 equal to 1 and y dash of 0 is equals to minus 2. And therefore, to solve this, we have to take the Laplace transform on both sides. First step, taking Laplace transform on both sides. Laplace of left hand side, individual Laplace, Laplace of first term, that is d2y by dt square plus Laplace of y and is equals to Laplace of t. Applying standard result, Laplace of second order derivative is s square y bar of s minus s into y of 0 and minus y dash of 0 . This is the Laplace transform of that second order derivative. Then Laplace of y is y bar of s and Laplace of t is 1 by s square, standard result. Then collecting the terms of y bar s, there are two terms of y bar of s, therefore taking that common we get s square plus 1 into y bar of s is equal to 1 by s square. Substitute the values of y of 0 and y dash of 0 and then transferring it to right hand side. Y of 0 is 1, therefore it becomes minus s. If you transfer, it becomes plus s. Y dash of 0 is minus 2, minus and that minus it becomes plus 2. Transferring, it becomes minus 2. And then dividing by s square plus 1, we get y bar of s as 1 by s square into s square plus 1 plus s upon s square plus 1 and minus 2 upon s square plus 1. Okay, and we call this as equation 1. Here the half part is completed, in which we have to obtain the Laplace transform of that given equation. And after getting this, we have to find inverse Laplace transform to get the solution or to obtain the value of y of t. Taking inverse Laplace on both sides, inverse Laplace of y bar of s, inverse Laplace of the first term 1 upon s square plus 1, individual inverse of this, inverse Laplace of s upon s square plus 1 and minus 2 constant outside, inverse Laplace of 1 upon s square plus 1. Standard result, inverse of s upon s square plus 1 is cos t, inverse of 1 upon s square plus 1 is sine t. And where to determine this inverse? Here it is the product of two functions of s. Therefore, applying convolution technique or method to find the inverse of this. Applying convolution theorem or method to find the inverse of this product of two terms, we know that inverse Laplace of 1 by s square st inverse Laplace of 1 upon s square plus 1 as sine t. Any one of them we have to call as f of t and second one as g of t. They're calling this sine t as f of t and this t as g of t, say. And therefore, inverse Laplace of the product 1 by s square into 1 upon s square plus 1, as per convolution theorem, it is integration from 0 to t f of u multiplied by g of t minus u, and its integration with respect to u. And therefore, integration from 0 to t f of u, replacing t by u, we get sine u, and g of t minus u, replacing t by t minus u, we get that term as t minus u. Integrating this product by a generalized part, t minus u is algebraic term, sine is trigonometric term. Therefore, as per that LIAT rule, algebraic must be the first, and therefore it is equals to t minus u first term. Integration of sine is minus cos u minus derivative of this with respect to u minus 1. Next, integration of cos is sine with this minus sign. Therefore, it is minus sine u. And limits from 0 to t. Subtracting the upper limit for u as t, we get t minus t as 0. Minus it becomes plus. 3 times minus means it is minus sine of t minus lower limit u equal to 0, cos 0 is 1, therefore with minus sign, t minus sine 0 is 0, and therefore that term becomes t minus sine t. Substituting this value in equation 1, we get t minus sine t. Inverse of s upon s square plus 1 is cos t, and inverse of this term is sine of t, and therefore final result, there are two terms of sine t, combining it, we get t plus cos t minus sine t and minus 2 sine t, it becomes minus 3 sine of t. As a final answer, a required solution is y of t is equal to t plus cos t minus 3 sine t. In this, I have applied a convolution theorem to find the inverse. In next example, I am applying partial fraction technique to obtain the inverse Laplace transform. Means either we have to apply convolution theorem or partial fraction method to find the inverse. Example number 4, solve differential equation d2x by dt square minus 3 dx by dt plus 2x is equal to 4 into e raised to 2t. Here x is dependent variable, t is independent variable, and the conditions are x of 0 is equal to minus 3 and x dash of 0 is equal to minus 5. Therefore, to obtain the solution, once again we consider the given as second order differential equation, d2x by dt square minus 3 dx by dt plus 2x is equal to 4 e raised to 2t. First step is taking Laplace on both sides. Taking Laplace transform on both sides, and therefore individual Laplace of left hand side, Laplace transform of d2x by dt square minus 3 constant outside, Laplace transform of dx by dt plus 2 times Laplace of x, and right hand side 4 constant outside, Laplace of e raised to 4t, 2t. Applying result, standard result for Laplace of second order derivative, it is s square x bar of s minus s x of 0 minus x dash of 0. This is the Laplace of second order derivative. Then minus 3 into Laplace of dx by dt first order derivative is s x bar of s minus x of 0 plus Laplace of x is x bar of s, and that is equal to 4 constant outside. Laplace of e raised to 2t. Laplace of e raised to 8 is 1 upon s minus e. Here it becomes s minus 2, 1 upon. Then there are 1, 2, 3 terms of x bar of s. Collecting in one bracket, we get s square, then minus 3s and plus 2. X bar of s is equal to 4, 1 upon s minus 2. Substituting the values of this x of 0 and x dash of 0 and then transferring it to right hand side. X of 0 is minus 3, minus minus becomes plus 3s, transferring we get minus 3s. X dash of 0 minus 5, minus minus becomes plus 5, transferring it become minus 5. Then x of 0 once again minus minus it becomes plus 3 into, therefore it becomes 9, minus 9, transferring to right hand side it becomes plus 9. Rewriting it, it is 4, 1 upon s minus 2 minus 3s, 9 minus 5 we get plus 4. Cross multiplying means finding LCM, we get 4 minus 3s into s minus 2 plus 4 into s minus 2 and whole divided by s minus 2, we get 4 minus 3s square, 3 to the 6s plus 4s and minus 8 and divided by s minus 2. We get this is equal to minus 3s square, only one term of s square, 6s plus 4s, we get 10s, 4 minus 8 we get minus 4 whole divided by s minus 2, and then dividing by this we get the value of x bar of s. X bar of s is equal to minus 4 plus 10s minus 3s square divided by s minus 2 into s square minus 3s plus 2. We check, can we determine the factors for this? Therefore factors are s minus 2, s minus 2 and s minus 1. Product is 2 and sum is minus 3. Therefore, factors of s square minus 3s plus 2 is s minus 2 into s minus 1. Numerator is minus 4 plus 10s minus 3s square. And therefore, it is minus 4 plus 10s minus 3s square whole divided by. There are first factor s minus 1 and s minus 2 is a repeated factor. Therefore, it is s minus 2 whole square. We call this equation 1. Half part is over here. Then in second part we have to obtain the inverse Laplace on both sides. And as here there are 3 factors in denominator, we have to apply only partial fraction method. That convolution theorem is not applicable here. And therefore, taking inverse, we get inverse of x bar of s is equal to inverse Laplace of minus 4 plus 10s minus 3s square whole divided by s minus 1 and s minus 2 whole square. Finding inverse by partial fraction technique using partial fraction method. This minus 4 plus 10s minus 3s square whole divided by s minus 1 and s minus 2 whole square, we can write. It is a combination of 2 types. First one is a real different root. Second one is a real and a repeated root. Therefore, for this different, a upon first factor. For this repeated, it is b upon s minus 2. And as it is repeated, we increase the power by 1. Therefore, c upon s minus 2 whole square. Finding LCM of this as s minus 1 into s minus 2 whole square. Therefore, we get minus 4 plus 10s minus 3s square. We call this equation 2. A into dividing by this to this product, s minus 1 get cancelled, remaining is s minus 2 whole square, multiplying by that to a. Then dividing by s minus 2, 1 s minus 2 get cancelled. Therefore, b into s minus 1 and s minus 2. Dividing by this s minus 2, square get cancelled with this s minus 2. Remaining is s minus 1. Therefore, c into s minus 1. Then simplifying it, it is a into, expanding it, its expansion is s square minus 4s plus 4 plus b into a product of these two terms, it is s square minus 2s minus s, that become minus 3s, minus minus it become plus 2, and plus c into s minus 1 as it is. Then collecting the terms of s square in one, second terms of s, and in third terms of constant. There are 2 terms of s square. Therefore, combining the 2 terms, we get a plus b into s square. Then collecting the terms of s, 1, 2 and 3. Therefore, it is minus 4a minus 3b and plus c into s, and then collecting the constant term in third bracket, we get 4a, then plus 2b and minus c. A plus b is equal to minus 3. Second, minus 4a minus 3b plus c is equals to, coefficient of s is here 10. Next, 4a plus 2b minus c is equals to constant term minus 4. If you add these two equations, plus 4a minus 4a get cancelled, plus c minus c get cancelled, 2b minus 3b we get minus b, as 10 minus 4 we get 6, and therefore we get the value of b as 6 minus. B as minus. Substituting that value of b is minus 6 here, we get a is equal to minus 3 minus b minus 3 minus 6. 6 minus 3, we get 3. Therefore, we get a as 3, b as minus 6. Substituting that value in this equation, we get the value of c, either in this or in this. Therefore, I am substituting here. We get the value of c as 10 plus 4a, a is 3, and plus 3b, b is minus 6. Simplifying it, it is 10, 4 3s are 12, and minus 18. 22 minus 18, we get that value as 4. Substituting a as 3, b as minus 6, and c as 4, we have this step. And then next step is inverse on both sides. Therefore, taking inverse Laplace on both sides, it is inverse of left hand side x bar of s, inverse of right hand side term, individual inverse, and therefore it is equal to 3 constant outside. Inverse of 1 upon s minus 1 is e raised to at, a01. Therefore it is e raised to t minus 6. Inverse of 1 upon s minus 2 is e raised to 2t. S replaced by s minus 2 in that s square term. Therefore it is a problem of shifting theorem. As per that shifting theorem, it is e raised to 2t into inverse Laplace of neglected 2, remaining term is 4 upon s square. And therefore, inverse of left hand side is x of t, 3 e raised to t minus 6 e raised to 2t plus 4 times e raised to 2t. Inverse of 1 by s square is t. As a required solution or the answer. Therefore, final answer is x of t is equal to 3 e raised to t minus 6 e raised to 2t plus 4 times t into e raised to 2t. Therefore, I have discussed two different problems. In the first problem, we have to apply convolution theorem as it is a product of two functions of s, and in second, that convolution technique is not applicable as we have 3 factors. More than 2 factors are there, then we have to apply partial fraction method. Means either by partial fraction technique or by convolution theorem, we can find out inverse of that. Therefore, in this two parts, I have discussed some of the important techniques to find the inverse Laplace transform. If you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Give your feedback in comment box. Thanks for watching.